Hey everyone, welcome. In this video, we're documenting a lost casting project we recently finished. From 3D printing the model all the way to pouring molten metal. It was a detailed process with a lot of problem solving, and we learned a ton along the way. Let's take a closer look. Lost casting is a metal casting technique where a solid model, usually made from plastic or foam, is surrounded by a mold material. The model is then melted or burned out, leaving a cavity that's filled with molten metal. In this project, we used a 3D printed PLA model, a plaster-sand mold, and a metal pour to explore the process ourselves. We started by designing and 3D printing the model in PLA. We added a pour hole and air vents, which are essential to let the metal flow in and allow air to escape during casting. These details help avoid defects like bubbles or incomplete fills. To make the mold, we mixed 800 grams of plaster with 800 grams of sand and added water until it reached a thick, pourable consistency. The sand helps reinforce the plaster, reducing the risk of cracking when heated. Also, we glued the model upside down to the bottom of a paper cup and used a mesh net to help reinforce the plaster so it doesn't crack as easily. This setup also keeps the model centered and prevents the plaster from collapsing when the PLA is burned out. We made sure the print was submerged, leaving at least an inch of space above it. After the mold dried completely, it went into a kiln at 400 degrees Celsius. Over a period of time, the PLA inside melted and burned away, leaving behind a clean, hollow cavity shaped exactly like our 3D print. The casting was done as a four-person operation for safety. One person opened and closed the kiln door. Another carefully removed the crucible and handed it off. A third took the crucible and gave the "got it" signal. And a fourth managed the slag. Once the metal was ready, it was poured directly into the molds. After the metal cooled, we broke open the mold to reveal the cast. Most of the original model's detail transferred well, and it was satisfying to see a solid metal version of something that started as a 3D print. Let's take a quick moment to look at the aluminum cast. Over at the top, you can see the remnants of some of the pins. This is most likely caused by air getting trapped during the aluminum pour. Another comment to add is on the right shoulder and the legs, we could see little beads of aluminum. This is most likely from air being trapped during the plaster pour. Looking back, we noticed a few areas that could be improved. For example, tilting the model inside the mold slightly could also reduce cold shuts or bubbles. Also, adding more vents in locations where air tends to get trapped would help the metal flow better. Here you can see a revised version that includes some of those improvements, extra air vents, and a slight tilt for better flow. This project gave us a hands-on look at how modern digital tools like 3D printing can work together with traditional casting techniques. We hope this gave you a better understanding of the lost casting process and some of the challenges that come with it. If you found it interesting, feel free to leave a comment with any questions. Thanks for watching and see you next time.